some of you had a look at the question pack that I put up. The ratio and proportion is massive. There's loads of questions, and some of them are definitely quite challenging, especially like the later ones. So yeah, I would recommend take the time to work through this, because although these are maybe not as difficult as the most difficult numerical reasoning test questions, if you've done all of these and you've worked for every single one, when you actually do a numerical reasoning test, all of these skills are going to be at your fingertips, super sharp, and that means that your brain doesn't have to think about how to do all of these little individual things. It can focus on the more challenging thing, which is figuring out the question, and you've just got all your tools ready. So anyway, we're not going to start with numerical reasoning test style questions today, because we're going to basically do that for the rest of the lesson once we finish, or the rest of the webinar, I should say, once we finish going through this. It's just taking me back to the beginning. Okay, so let's just skip ahead. Okay, so given the ratio between two numbers, express it in the form x to 1, where x is a value to be found. So, for example, express the ratio 7 to 4 in the form x to 1, where x is a value to be found. So often when we're given a ratio, what we've looked at up until now is putting it in its simplest form. So that would mean the form in which we use the smallest whole numbers. So for example, an example of a ratio that would be in its simplest form would be like 5 to 4. That is in its simplest form. However, sometimes what you might want to do instead is change it to be something to 1. So in this case, to get something to 1, we have to divide both sides by 4, and that would give us 1.25 to 1. So we're going into decimals. So obviously this is not the simplest form, because the simplest form is the one that uses the smallest whole numbers. 1.25 is not a whole number. However, this form of the ratio, which I'm going to call the x to 1 form, something to 1, can actually be more useful than the simplest form, because when we're comparing different ratios, the advantage of having them all be something to 1 is that we can just, it's much easier to see which is bigger and which is smaller. Okay, so in this example, 7 to 4 is going to be pretty similar to the one that I just did. So we want to divide both sides by 4. 7 divided by 4 is 1.75, because it's 7/4, 7 quarters, 1 3/4. So it's 1.75 to 1. The next one, 35 to 8. So we want to divide both numbers by 8. 35 divided by 8 is 4.375 to, and then 8 divided by 8 is 1. And then 3 to 5, we divide both sides by 5. So 3 divided by 5 is 3/5, which is 0.6. So it's 0.6 to 1. Obviously, you can use the calculator for all of those. And now we have these three ratios that are much easier to compare. So it might be, for example, so often when we're talking about ratio, it relates to some real world thing. So when, say, for example, this was like a school trip, and we said, okay, there's 7 teachers for every 4 students. Well, that isn't actually a very useful way to communicate that information. There's 7 teachers for every 4 students. It's a bit of a headache to think about. Whereas if you said there's 1.75 teachers for every 1 student, this is not a very realistic example that I've picked, but if there was 1.75 teachers for every 1 student, you can instantly appreciate what that means. It's something per something. It's teachers per student. So these can actually be much more useful ways of communicating ratios. Okay. Given a list of ratios, place them in ascending or descending order. So place the following list of ratios in descending order: 7 to 13, 92 to 39, 3 to 8, 12 to 23. So all we have to do is convert these into x to the 1 form, as I just showed you, and then we just put them in order based on the size of the first number. So do I have these? Yeah, I've already put them on the slide. So I'm not going to go through the process again. But 7 to 13 becomes 0.538 to 1, and so on and so on. So we end up with these 4 different ratios. So putting them in order, the biggest one is this one because it's 2.36 to 1. 2.36 is bigger than any of these other numbers. So 92 to 39 is the biggest. Then the next one is 7 to 13 because that's 0.3538, which is bigger than these two numbers. And then 12 to 23, which is 0.522 to 1, and 3 to 8, which is 0.375 to 1. And obviously, if you were asked to put them in ascending order, then you would just go the other way. Okay, so it's pretty straightforward. Finally, this one, when I first came across this in a numerical reasoning test question, I thought this was quite challenging. But and I actually did it the first time using algebra, but then I realized these questions are really easy. There's a really simple way to do them. So, excuse me. Given the ratio between two or more values and the difference between two of the values, calculate all of the values. So this is quite an unimaginative example, but if you look in the question pack, I came up with some better ones here. Three numbers A, B, and C have a ratio of 5 to 20 to 13. The difference between A and C is 120. What are the numbers A, B, and C? So first of all, as I was saying last time, I always just recommend writing down in letters what ratio we're talking about so that we don't get confused later on, so we don't have to hold it in our mind. It's just there written down. 5 to 20 to 13. Okay, and it tells us that the difference between A and C is 120. So the difference between A and C is 120. So let's just put 120 over here, so we've got that written down. Okay, this is A to C, or C minus A it's going to be because C is bigger. So remember I was using the word parts to talk about the numbers in the ratio. So it's like 5 parts A to every 20 parts B to every 13 parts C. So what you want to do is work out what's the difference between A and C in terms of parts of the ratio. So what's the difference between 5 and 13? The difference between 5 and 13 is 8. So we just do 13 subtract 5. That gives us 8. So what this means is that the number 8, or 8 parts in the ratio, represents 120, represents the number 120. So then we have to work out, okay, well, what does 1 part in the ratio represent? Oh no, did not like that. And so what we do is divide 120 by 8, and we get 1 part in the ratio represents the number 15. And from here, it's really easy to work out the numbers A, B, and C. So A is going to be 5 parts, so 5 times 15 is 75. B is 20 parts, so 20 times 15, which is 300. And C is 13 parts, so 13 times 15 is 195. So super easy once you know the method. But if you haven't come across it before, it can be a bit daunting to wrap your head around. But once you get the hang of it, it's actually super easy. So yeah, even if you're not going to do the rest of the question pack, have a go at these 5 questions here. It will be good practice. Okay, so that brings us to the end of ratio and proportion. There are a few other bits that I'm going to add to the toolkit, because we haven't looked at averages like mean, median, mode. We haven't looked at kind of graphs and tables and things, and there's a couple of kind of algebra things that you might need to know. So we will come back to building up our toolkit, but I thought given that we've now actually learned quite a lot of skills, quite a few skills, it would be a good idea to actually just try a bunch of numerical reasoning test questions. So we're going to use Menti for this as usual. So I will paste the link into the chat. So the link is there, or you can just go to menti.com, put in this code. So once you're in, can you please like the page or heart the page, just so I can see how many people are in. Only got 1 person so far. 2. Okay, so just to recap, go to menti.com, use this code, or just go to this link that I pasted in the chat. And once you're in, just click on the heart so I can see that you're in. So I'm actually going to use these questions that, where are they? So EY actually put together a bank of questions for us to use, which is great. So we are going to use some of those. Okay, we've got 3 people in now. Maybe we'll go with that. So they vary quite a lot. Oh no, you can see the answers. Well, hopefully none of you would have looked at the answers because you're all very honest. So only the first couple anyway. So anyway, they vary quite a lot in difficulty and the different skills that you need. But let's just have a go at them and see how we get on. So it's like what we've done previously, but just in case anyone wasn't here. Oh yeah, and I need to remember to move this on. Otherwise you can't enter your answers. There we go. So the first question is about book publishing. This is the question. So I'll keep this up, and then on your devices, if you just enter your answers, and I will give you 1 minute to do this question. Off you go. Okay, 30 seconds left. Last 5 seconds. Okay, so let's have a look at your answers. We've got 1 for D, 1 for C. Anyone else want to have a guess? Okay, the correct answer is C. So let's have a look at the working out for this one. Okay, 2 people went for D in the end. So the following table provides the percentage distribution of the expenditure incurred in publishing a book. Study the table and answer the questions based on it. So this is showing what percentage, like a breakdown of what percentage of the expenditure went on different things. And this question is talking about royalty and printing. So printing is 20% of the expenditure, royalty is 15% of the expenditure. So if for a certain quantity of books, the publisher has to pay out £30,600, so yeah, £30,600 as printing costs, that's printing here, then what will be the amount of royalty to be paid for these books? So, although these are showing kind of percentages of the total, you can also think of them as it just kind of shows you the proportions between the different things. So in this case, the proportion, so printing to royalties like 20 to 15, or if you simplified that, you can think of it as 4 to 3. But let's just keep it as 20 to 15. So for every £20 spent on printing, there's £15 spent on royalty. So the printing was 30,600. So what we want to do is divide that by 20 and then times it by 15. So we just think of it as a ratio. So 20 to 15, T to 15. And so we have that amount, that 30,000, etc. 30,600. What would be the equivalent? So we kind of need to know, okay, that's 20 parts. So one part would be that divided by 20, and then 15 parts would be that times 15, and we get 22,950. So the answer is C. Okay, let's have a go at this question, which is part 2. I will give you again 1 minute. $20. 5 seconds. Okay, so let's have a look. We've got one person saying A, one person saying B, 2 people saying B. Correct answer is B. So well done, those of you who got it right. So let's look at the method. We've already read this information. Now it says the price of a book is marked up 20% over and above the cost. So what that means is that the cost, which is the thing we've been looking at until now, the amount it costs to actually produce the book, times 120% equals the price that it's sold for. Okay, so, and now we're told that the price of the book, the marked up price, is £180. So in other words, this equals 180. So if we want to find C, the cost of the book, well, first of all, what's the question asking us? What was the cost of the paper for the book? So first we need to work out the total cost of the book, and then we can find the cost of the paper. So if we want to find the cost of the book, we know that C times 120%, or in other words, C times 1.2, because it was 120%, because it was 20% over the original, is 180. So to find C, we just do 180, 180 divided by 1.2, and that tells us that the cost of producing the book was £150. Now we know that 25% of that cost was for paper, so to find 25% of 150, we could just multiply by 0.25, and that gives us £37.50. Also, 25% is a quarter, so you could save small moments of time by just dividing by 4. You get the same answer. Okay. So, we have 4 people answer that. Great. Okay, so UK salaries is the next question. I'm going to give you a minute and a half for this one. Off you go.
Sorry, I can't see the question.
Oh, can anyone else see the question?
Yeah, I have a question.
I don't know why that is. I can
It's still
stop.
stuck on like the whiteboard.
It might just be a slow internet connection on either my end or your end. I could try stopping sharing and sharing again. Let's try that. Does that help?
I think it's slowly coming back. It's kind of just blank at the moment.
Sorry.
Yeah, I think it may be on my end. I think I'll rejoin the call instead.
Okay. Okay, I'm going to give you another 30 seconds. Okay, have we got some answers? Okay, get your answers in now then. Give you a few more seconds. Nobody's got an answer? Do you need more time? Okay, we've got one answer. Okay, I'm going to give you 20 more seconds and I'm going to go through it. Okay, so we only got one answer, which is E. Well, that is correct. Well done, whoever that was. So it is E. So the average salary in the UK in the year 2000 was £18,000. By 2020, this had increased to £31,000. If house prices have increased proportionately with salary, I found it hard to say because it's such an unbelievable if. But and cost an average of £256,000 in 2020. How much did a house cost on average in 2000? Okay, so what we have is we're comparing 2 years, 2000 and 2020, and we've got the salary and the house price, and we've been told the average salary in the year 2000 and the average salary in the year 2020. So we've got this one and we can work out the percentage increase. And then we've been told the average house price in 2020. So you got to read it carefully because then it's not from 2000, it's the average in 2020. We've been told that. So we've got to work out the average house price in 2000 if it was the same percentage increase for both. Okay, so first of all, let's work out the percentage increase of salary. So the difference is going to be the bigger number minus the smaller number, or the more positive minus the more negative number. And that gives us a difference of £13,000. So it increased by £13,000. So we need to know what was that as a percentage of the original amount. So 13,000 divided by 18,000 gives us 72.2%, or if we times it by 100, it will actually express it as a percentage. And so the idea now is that the final house price would have been the original house price times 1.72 to recurring. So if we just add 1 to this, we'll get that number. Oh no, sorry, I'm supposed to add 100. Let's take that off because it's a percentage. So in other words, the final house price is 172.222% of the initial house price, which we need to convert to a decimal so that we can work with it. And so we want to divide the final amount, 256,000, by that amount, and that gives us the initial amount, which is 148,645. If any of these individual skills that I'm using, like percentage increase and so on, are unfamiliar to you, then just go back over the stuff from the previous lessons, question packs, notes, rewatch the recordings, etc. So next question. Mouse mortality. So I will give you 2 minutes for this one. Off you go. Okay, 1 more minute. If you've just joined, you're not sure what we're doing, if you just look in the chat, I posted a link to menti.com. If you follow that link, you should be able to join our Menti meeting, and then you can actually input your answers as we're going along. "30 seconds left." Okay, 10 seconds. Get your answers in now. Okay, so we had 2 people say A, 1 person said B, 2 people said D. So, and yeah, if you've just joined, you can go to menti.com. Here's the code, or I posted the link already in the chat. But let's check who got it right. Nobody. Okay, so cool. This is I'm pleased that nobody got it right, because it means there's some use to me explaining this. Okay, good. So the below is a mortality table for a species of mouse commonly found in southern England. if I have 100 newborn mice today, how many might I expect to have left in 2 years? Okay, so we're starting off with 100 mice. Let's just write that down. That's today, I've got 100 mice. How many will I expect to have left in 2 years? Okay, so it tells you the age range, so within the first year of life, there's a 0.3 chance, a 30% chance, in other words, that the mouse will die. In the second year, so between age 1 and 2, there's a 0.24 chance or a 24% chance that the mouse will die, and so on. Okay, we're only interested in the first 2 years, so we can kind of disregard the rest of the information. Okay, so in the first year, each mouse has a 30% chance of dying. In other words, each mouse has a 70% chance of living, because 100% minus 30% is 70%. So 70% of the mice will live, in other words. Because if each mouse has a 70% chance of living, that means that 70% of the mice will live. Or, you know, on average, if you repeated it lots of times, this is what you'd expect. So we had 100 mice to begin with. So if 70% of them will survive the first year, then that means that after 1 year, we will now have 70 mice. 30 of them have died, 30%. Now, the second year, the chance of dying goes down a bit. They're a bit more likely to survive. So now there's a 24% chance of dying. This means that they've got a 76% chance of living. Because 1 minus 0.24, 0.76. They've got a 76% chance of living. So that means that 76% of the 70 mice will live. So what is 76% of 70 mice? It is 53.2 mice, but obviously we can't have 0.2 of a mouse, so we just round to the nearest value, nearest whole number, and so the answer is 53. Okay, so hopefully that makes sense. Let me know if it doesn't. Next question. Maybe we'll have a few more of you. I'm just going to chuck this in the chat again in case anybody needs it. Please do join in on Menti. It makes it more fun. So here comes the next question. And again, I'm going to give you 2 minutes for this one. I'm actually going to make it bigger as well. One more minute. Ten seconds. Okay, get your answers in. Okay, we've got 2 people who've gone for C. 1 person's gone for D. The correct answer is E. Okay, so let's have, maybe I should give you a bit more time for these. Would that help? Are you finding the time pressure a bit difficult? Although obviously that is part of what we're practicing as well. So the chart below shows the online and store revenue by quarter for the previous year. At $4 million, quarter 3 had double the total revenue of quarter 1. So this is quarter 3 here. This is quarter 1. In percentages, rounded to the nearest whole number, but how much more online revenue was made in quarter 3 compared to quarter 1? Okay, so first of all, in this graph, we can ignore everything apart from quarter 1 and quarter 3. So we can see from the key that store sales is dark blue and online sales is the light blue here. So in quarter 1, this is asking about online revenue. So in quarter 1, online sales was 28% of total sales, and in quarter 3, online sales was 31% of total sales. Now it tells us that the total revenue or sales for quarter 3 was $4 million, and it says this was double the total revenue for quarter 1. In other words, quarter 1 is half of $4 million, which is $2 million. Okay, so we want to know as a percentage how much more online revenue was made in quarter 3 compared to quarter 1. So quarter 1 online revenue, we're just interested in online revenue. So quarter 1 total revenue is, we know it's $2 million because it's half of 4 million. And so 28% of that was online revenue. So we times that by 0.28 and we get 560,000. Okay, and then quarter 3, oh, I didn't put the 1 on there. Quarter 3, we do the same thing, but obviously $4 million. And then times that by 0.31 because we want 31% of that, which is the online sales. So that gives us 1,240,000. 1,240,000. Obviously, this is in dollars. Okay, so then we just have to say, okay, as a percentage, how much more online revenue was made in quarter 1 compared to quarter 3? So it's just a percentage increase, essentially. So first we work out the difference. So 1,240,000 minus 560,000. That gives us 680,000. That's the actual increase. But then what is that as a percentage of the original? So we have to divide that by the original, and we get 1.214, etc., etc. And if we want to convert that to a percentage, we times that by 100, and we get 121.4%. So the closest answer is 121%, which is what it rounds to. Okay, hopefully that all makes sense. So next up, oh, we got a late entry there. Well done. That was correct. Oh no, did somebody already have that? I can't remember. How many grams of butter and caster sugar? So this one doesn't have multiple choice. So you just have to type your answer. Just put it all in one text. So if you think it's 20 grams of butter and 30 grams of caster sugar, just type in 20G, 30C or whatever. Okay, so I'll give you 2 minutes again. One more minute. So if you've just joined, you can find the link in the Teams chat for the Menti, so you can enter your answers. We got some answers coming in. We got some answers. So 20 seconds left. Okay, get your answers in now. Time is up. So we've got 3 answers. We've basically got two different answers. Oh no, we've got a few different answers actually. Okay, so the correct answer is 750 grams of butter and 560 grams of caster sugar. 563 grams of caster sugar. Note it does say in the question rounded to the nearest whole number. So 750, 563. So this person here got it correct. Well done. This one is correct, but you just didn't round it. So just make sure you always read the question really carefully, because things like this, I mean, it's going to be multiple choice anyway, probably, but still, it's good practice. And then these ones are wrong. So let's have a look at the correct method. So can you resend the, I'm guessing it says link. Yes, it does. Can you resend the link? There you go. The grandmother said, in order to bake the perfect cake, use 50% more butter than you would flour. Okay, use 50% more butter than you would flour. The flour is 500 grams. So I think we can see what's gone wrong with these answers, which is 2 different people, so, you know, it's an easy mistake to make, is you've done 50% of the flour, right? But it says use 50% more butter than you would flour. So in other words, the butter is more than the flour. It's the same amount as the flour and then 50% more again. So if this is the flour, the butter is that much plus 50% of that much. 50% more butter than you would flour. Okay, so the flour is 500 grams. So in other words, what we want is 150% of that. So the flour is 100% of the flour, because that's itself. Every number is 100% of itself. The butter should be 150% of the flour, or in other words, 1.5 times the flour, 1.5 times the flour. So the flour is 500 grams. We just times that by 1.5, times it by 150%. In other words, we get 750. You could also, if you wanted to, you could find 50% of it, which is 250, and then add that on to the original amount, and then you get 750. But you don't really need to do that. You just do, it's 150% of the original, so it's 750 grams. And then 25% less caster sugar than butter. Yeah, so the butter, wait, hold on. I think my answer is wrong as well. I'm just rereading this now, but this is also EY's answer. Wait, why do I think it's less? Oh, no, sorry, yeah, this is fine. So 25% less, God, I was just doubting myself there. So 25% less caster sugar than butter. So the butter is 750 grams, right? So we want 25% less than that. So in other words, that amount minus 25% of itself. So if this is the butter, the caster sugar should be like this much. In other words, the caster sugar should be 75% of the butter, because it was 100%, and then we took off 25%. That gives us 75%. 100 minus 25, 75%. Okay, so all we need to do is take that value of 750 and times it by 0.75. So just find 75% of it. Oh, whoops, something's gone horribly wrong. And then we get 5. Hold on, that is. Oh no, yeah, 562.5. But rounded to the nearest whole number is 563. Now, if you wanted to, you could actually find 25%, which is 187.5, and then take that away from the original amount, and you get the answer. But you don't need to do that. Okay. Next is employee headcount. So have a go at this one. I will give you 2 minutes again. Off you go. Okay, 1 more minute. Whoops. Pretend you didn't see that. Maybe I'm trying to catch you out. Maybe it's a trick. Thirty seconds. Okay, time's up. Get your answers in. So a lot of people have gone for B. I might have given the game away a bit by showing you the answer, but I'm sure you would have got it anyway. So it is B. So companies A to D have an ambition to increase the employee headcount over the upcoming year to help them meet business demand. Each company have set targets for the upcoming year in the table below. In percentage terms, which company has the lowest employee target to achieve? Rounded to 1 decimal place. Okay, so I suppose the most obvious way to do this is to say, okay, what's the increase that each one is aiming for? So we've got these 4 companies, A, B, C, and D. A is aiming for an increase of 60. 200 minus 140 is 60. And then find what percentage that is of the current. So 60 out of 140 is 42.8%. 42.9%. And then the next one, 345 to 400. So that's an increase of 55. So 400 minus 345. So what is 55 as a percentage of the current? 55, whoops. 55 out of 345 times 100 is 15.9%. C is looking for an increase of 61. Is that so? 350 minus 289, 61. Yeah. And so as a percentage of 289, that is, whoops, oh no. Times 100, get 21.1%. And then D, the reason I'm going through this, by the way, is I'm going to show you an easier way to do it, or a quicker way to do it. So the increase here is 190, 500 minus 310. So as a percentage of 310, that is 61.3%. So clearly the lowest, which is what it asked for, is B at 15.9%. However, there is a quicker way to do this, because really you could just work out what percentage is the target of the current, and the ranking of them will be exactly the same. The numbers will not be the same. It will be 100% plus this number, but the order that they're in will be the same. So for example, what percentage of 140 is 200? So we just do 200 over 140 and then convert that to a percentage. It's 142.9%. If we go back to here, we got 42.9%. So it makes sense, right? Because it increased by 42.9%. So now it's 142.9% of what it was. But this is a much quicker way to do it. You just divide the final by the initial. Now, it doesn't tell you the percentage change, but we don't actually need to know the percentage change. We just need to be able to put them in order and work out which one's the largest. And also, you can pretty quickly see that the percentage increase is 42.9%. So that would be my recommendation there. And actually, it's 5:26, so I suppose we should finish there. So thank you, everyone that's been here today. It's been fun having a little bit more interaction, and we will keep practicing these next week, and then